All right, so we had homework in here on, was it 479, was it?
Yeah.
Yeah, 479, and we also had a worksheet or two. I will answer any questions on that to begin the day.
Can you do 31 and 45 from the
Worksheet or the book?
book?
31 and 45?
Mm-hmm.
Okay. Does anybody have any questions from the worksheets?
10 and 19.
10 and 19 for the worksheets? Dustin? Here, take your time. You can yell out a minute. Anybody? Yes, sir. 24? Oh, the worksheets? You may have to yell those out to me, seeing as I didn't bring my worksheets. So.
Can you do 26?
Or a worksheet as well? Yes. Okay.
2 worksheets?
Yeah, there were 2 worksheets, I believe. So, so those of you who yelled out, whoever yelled out number 10, if you could just read it to me, it'd probably be the easiest. Or somebody tell me what it says. I don't have mine in front of me.
E to the power of x minus 1
E to the power of x minus 1
minus 5 equals 5.
equals 5? Yes, sir. Okay. This is a good one to start out with, especially today. It will lead right into what we're going to work with. Basically, these exponential equations, you're going to see here that you have something raised to a power. You want to set that part of the equation alone, all by itself, so that we can do something to it to erase it. In other words, if you have multiplication, division, subtraction, whatever you have on this side, use some algebra to move it all to the other side. In this particular case, I only have to add 5 because that's the only thing over here. So e to the x minus 1 will equal to 10. Now that I have e raised to a power, and I want to get that power, which has the variable, down to the working line, what can I do to both sides now?
Well, put the x minus 1 out front.
Take the natural log, actually. And what does the natural log do to e? They cancel away, and this becomes just x minus 1. That's a 10, sorry. Is equal to the natural log of 10, and then add 1 to both sides. So x must be 1 plus the ln of 10, which is a calculated problem.
What? I didn't do it that way, but I got this.
There's plenty of ways to do it.
The value of e.
No, I put
3.3025, is that what it has on the worksheet?
I believe so.
2 6.
Oh, 26, yeah. They round up to 4 decimal places.
What does that say?
Which one?
The bottom.
It says 1 plus the ln of 10. Okay.
I just need help with that.
Oh, because of the stuff, yeah. Does that help a little? Probably not. Okay. The ln of 10. All right. Basically, there are several other ways to do this. How would you do this? Change it to an exponential to a logarithmic equation? Yeah, how did you do it?
I put the x minus 1 in parentheses, or let's go to this, that one right there. The x minus 1 in parentheses out front.
How can you do that?
This is how Weston showed me, and as it worked. And then I did ln e equals ln,
Oh, right. Yeah, in other words, right here we have ln of e. You move this out front,
and
divide.
then I divided.
Yeah, what is the ln of e, though?
Okay.
You don't need a calculator. It's always going to be 1. Because the ln of e is the natural log. E raised to e. E to what power equals e? 1. E to the first power is e. So, what Wilson told you was right, but it's the long way around. The shortcut is just to cancel the ln away and leave the exponent here. Because the natural log and the exponential are inverse operations. Very much like if you have x squared, you take the square root, what do you write? Right. Or if you have the square root of x, well, how do you get rid of that? You square it. So these two operations are inverses. So is ln and e, they're inverse operations. So really by taking the ln on both sides, you simply just wipe it away and leave the exponent. Technically speaking, you move the exponent out front, divide by the ln of e, but the ln of e will always be 1. There's no reason to divide by it. Works for you. Let's move on to number, what is it, 14? Or 19?
Can you just read 17 again?
Okay, well, read it to me then, Dustin.
-2 times e raised to negative 3n minus 8.
Okay,
Negative 3n minus 8.
8, oh, 8.
And then negative 3 in big
On the,
numerical values. I don't know how you say it.
solve the exponential equation.
Right. It's back to the you're doing it.
Minus 3.
Minus 30 equals. Yeah. Negative 45.
Negative 45?
Yeah.
Okay. All right, this is another great example to start today. It's very much like this one. Instead of just subtracting something, though, they've subtracted and multiplied. So we're going to use the algebra skills we have to basically get the e part all by itself. So the first step here is to add 3 to get minus 2e to the minus 3n minus 8 is equal to minus 42 divided by negative 2. So again, our goal here is to isolate the e raised to a power. This is going to be 21 positive. And then finally I have the e, or the exponential equation, all by itself. The next step is to take the natural log of both sides. These cancel each other. If you will, this moves out front and the ln of e is 1, so it'll be 1 times that, which basically is just that. So you have minus 3 and minus 8 is equal to the ln of 21. And now you know how to solve the idea here is this. The ln of 21 is just a number. If I put it into the calculator now, I'll have minus 3n minus 8 equals some number, and you know how to solve an equation like that, right? You just add 8 divided by negative 3. So I'm going to wait till they get to the final result, so I only go to the calculator once by leaving it as the ln of 21. So minus 3n equals to 8 plus the ln of 21, n will therefore be 8 plus the ln of 21 divided by negative 3. And I did that, so I just have to go to my calculator one time. Okay. Notice that I used parentheses here, right here, and said 8 plus the ln of 21, that whole quantity is divided by negative 3. So the answer should be minus 3.6815. Does that match up to the worksheet?
Can you do 18?
Sure.
And that wasn't 23, it was 26.
What is it?
Does Ellen have a value itself?
L is a function.
It's just a function.
Yeah. It's like saying, does f of x have a value? It depends on the definition of the function. All right, so 18 you said you wanted to squeeze in? Could you tell it to me?
2 log 7.
Log base 7 or log
No,
of?
just 7.
Okay.
Over 3.
Over 3.
And just to condense it.
Condense it, okay. What we can do here, let's see. This becomes 2/3 log of 7, which becomes log of 7 raised to the 2/3 power. And that's about as condensed as I'm going to get, unless I want to say log cube root of 49, which is the same thing as 7 to the 2/3 power. Do you have the answer to this one in this?
Well, it left it at 7 squared, like on, would you leave it at 7 squared?
Yeah, that's fine, sure. Like this. 7 squared, 49, or what's the difference?
If you had log of 7 squared over 3, would,
Log of 7 squared over 3, like this?
yeah, would that be wrong?
Yes. Because this is not 7 squared over 3. This is the cube root of 7 squared, which is different than 7 squared divided by 3. Completely different, right? Because the cube root is not the same as divided by 3. For example, the cube root of 8 is 2. 8 divided by 3 is something other than 2. Wait, all right, so where are we at? 24 here? If somebody would be kind enough to read that to me.